All right, we're going to work on lesson 3.2 today, and we're going to focus on truth tables. All right, when we talk about truth tables, okay, these are logically based mathematical tables that are going to illustrate the possible outcomes of scenarios. All right, it's all going to be true, false. All right, and the scenarios are going to be our our compound statements, conjunctions and disjunctions, as well as scenarios that are conditional statements if then. All right, the truth table contains the truth values that would occur under the premises of the scenario. All right. And it's going to take all of the combinations of the truth values into account. All right. And this is just a nice way to visualize whether an argument is logical or true in different scenarios. Okay. So let's jump in here. This is a look at the compound statements and their truth value outcomes. All right. First of all, let's assume that we're dealing with two statements. All right. These two statements can either be true or false. And we want to look at the combination of that. So, for example, statement P is either true or false. You can see I went true, true, false, false. Statement Q is either true or false. I went true, false, true, false. Now, the reason I set it up like that is because I want to look at all combinations. I want to see what happens when P is true and Q is true. What happens if P is true and Q is false? What happens if P is false and Q is true? Or what happens if they're both false? Okay, so it's a matter of looking at the combinations of possible outcomes for two statements. And if you want to think of it this way, there's four different ways I can arrange true false between these two statements. Now, when it's a disjunction or P or Q, then the outcome is based on whether one of these two are true. As long as one of these two statements are true, then the overall outcome is true. All right. So true is true because one of them were true. True or false is true because one of them was true. False or true is true because one of the two statements were true. False or false is false because neither one was true. Okay. So it's all about that individual combination and the compound disjunction or conjunction used. So this is what or would look like. And again, or is true when one of the statements is true. All right, now this should be a conjunction. A conjunction is and. All right, and uh, is going to act differently than the or. Now, look, we set it up the same way. All right, P could be true or false, Q could be true or false. And what we want to look at is all the four different combinations of these two put together. So if this was P and Q, then I'm looking at each combination. So true and true is true. In an and statement, okay, both statements have to be true for the overall and concept to be true. All right, true and false is false. False and true is false. False and false is false. In order for and to be true, then both of the statements have to be true. Okay, so that's how and or work. Now, what we're going to do is look at this in different scenarios. For example, they're going to ask us to complete the truth tables. Okay, now, in this case, they're just saying, all right, here's now notice they set up P and Q just like I did. So that here's the four different possible combinations for P and Q statements. All right. The first column they're saying to do is the negation of Q. Remember, negation means the opposite of the truth value. So let's look at Q. In this first statement, we said it was true. Well, the negation of Q would be false. If Q was false, it would be true. If Q was true, it would now be false. The negation of that would be false, and the negation of false is true. So that's just filling out that column. Now, the last column says do Q and P. Remember, this is only true if both are true. So Q and P, true, true, true. True, false is false because they both have to be true. False, true is false. False, false is false. So we just filled out all the columns here, and that would be the end result. Okay, now when we get a problem like this, so they're asking us to do the negation of P and the negation of Q. Okay, what we want to do is we want to create a new table. And in our table, we want to have every combination here accounted for. See how we did negation of P and negation of Q? So I want to make a negation of P column, a negation of Q column, and then I'll put these two columns together to get the and result. All right. So I start with my P and Q statements, right? True, 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 false, false, true, false, false. And what I'm going to do is fill this column out first. So the negation of P would be, in this first circumstance, it should be false, false, true, true, right? I take these and I get their opposite of meaning. Negation of Q. Go to the Q column. Negation of true, false. Negation of false, true. Negation of true, false. Negation of false, true. And now I'm going to take my two new columns and join them with and. Negation of P and Q. Remember, for and, both statements have to be true. So false and false, false. False and true, false. True and false, false. True and true. That's the only case where it's true. Okay. So for me, in order to fill this column out, I'm going to create a new table so that everything that I need is in the table. And I go to the individual columns to get my truth values. Okay. Another way they'll do this is they'll just give you a column. Now notice here that they give us three statements: A, B, and C, and these are the ones they chose to use. True, A is true, B is true, C is false, and we're going to work this concept just for these. All right. All we need to do is fill out the columns here. So the first column says take the negation of A. Well, A was true in this case, so now we're going to say it's false. Next step, negation of A and B. So the negation of A is false. B is true, but it's and, so false and true is false. And now notice they're saying take C or the negation of A and B. Now this, in parentheses, negation of A and B, that's this answer right here, F, false. So we're going to take C or this answer, which is false. So C is false. Negation of A and B is false. False or false is still false. Remember, you got to have them both. One of them had to be true in order for or to be true. Okay. So here's another scenario. This time A, B, and C, three statements. They're saying A is false, B is true, C is false. So that's what we're going to work with. So the first column here is A or C. So A or C, so false or false is false. This one says take the negation of A or C. So the negation of false is true. And now they're saying take that answer, negation of A or C, and join it with and B. So true and true, the final answer here is true. So we're just working all of our conjunction concepts there. And in this case, we were just working one row in a true false table, or in a table, table, that is. Here's another one: true, false, true. Or is that the last one we just did? Nope. This is the next one. Okay. So this is a little bit more complicated, but we're just going to do a row at a time here. Okay. So first column says negation of P. In this scenario, P is true, so the negation of P is false. Negation of P and R. Negation of P is here, and R. R is true. So now, and remember though, both had to be true. So true and false is false. The next one says take the negation of the negation of P and R. Where here's the negation of P and R. We said it was false. The negation of that would now be true. And then for our last one, it says take the negation of the negation of P and R, which is true, or Q. True or false, or means one or the other. So this answer is true. So step by step here. Okay, here's another one. They're saying P, Q, and R are these given statements. False, true, true are the ones that we're going to analyze. Okay, negation of Q. So Q is true, negation of Q, false. Okay, P or the negation of Q. So negation of Q is false. P is false, right? So false or false is false. Mess that one up, huh? P is false. Negation of Q, false. So that should be false. The negation of that should be true. Boogered this one up, guys. Sorry. And then this one and R. So this is true and true. That one should be true. So, man, I apologize. That one is all messed up. But hopefully you listened to my corrections as I went. All right. Okay. Now, moving on to conditional statements. All right. What we had just did was compound statements, conjunctions, disjunctions. We also can build these truth tables for conditional statements. All right. Same thing applies. We look at two statements, P and Q, and their possible outcomes. P could be true, Q could be true. P could be true, Q could be false. P could be false, Q could be true, or they could both be false. All right. The conditional statements is P implies Q. All right. The way conditional statements work is, and I'm going to talk to you through this with you in a minute. All right. Is if it's true implies true, it's true. True implies false is false. If false implies true, it's actually true. And if false implies false, it's actually true. So the only time a conditional statement is false is if the hypothesis is true and the conclusion is false. Okay. And let me explain why. The conditional concept is like breaking a promise. Okay. Let's say that I said to you, if I find $20 bill, then I will take you to a movie. All right. Now I'm going to go through this scenario and see whether I break my promise. So in the first case, I find a $20 bill and I take you to the movie because both of these two are true, right? So I found the 20, I took you to the movie, so I kept my promise. That's true. In the second scenario, I find a $20 bill, but I don't take you to a movie. So I broke my promise. That's false. In the third scenario, I don't find a $20 bill, but I still take you to a movie. So I kept my promise. That's true. And in the last scenario, I don't find a $20 bill and I don't take you to a movie. So I didn't find the $20 bill and I didn't take you to a movie, so I kept my promise. Because if I found it, then I would take you. So that one's actually true. So you got to look at it as keeping a promise. And I know it's kind of a little bit strange there. Or the other way to think of it is the only time this a conditional is false is if the hypothesis is true and the conclusion is false. Okay, so you got to keep that in mind. All right, so let's say they ask us to complete this truth table. Okay, they want us to find in the end the negation of Q implies P. Well, what I want to do is I'm going to set up a table for this. I want to find Q implies P here, and then I'll negate it here because I don't want to try to do two things at once in my head. So this is Q implies P. So true implies true is true. False implies true is true. True implies false. That's the only time it's false. False implies false is false. I'm sorry, true. Now here it says negate that. So take these and negate them. So this true becomes false. This true becomes false. This false becomes true. True becomes false. Okay. So just following the chain there. Okay. Another one. So this says find the negation of P implies negation of Q. So again, I'm going to create a new table and I'm going to have a negation of P column, a negation of Q column. And then I'm going to take these two and do the if then on there, the conditional statement on them. So we always start with P and Q. Here are the combinations, right? Same combinations we've had the whole time. Negation of P would be false, false, true, true. Negation of Q, false, true, false, true. All right, now negation of P implies negation of Q. So false implies false, true. False implies true, true. True implies false. There's the only one that's false. True implies true is true. Okay. So again, I won't try to do all this in my head. Make a new chart, rewrite some new columns so that you have all the information so you can see it. Another one, it's a little more complicated, right? So here's my PQ statements. Now they want us to do P implies Q and take that answer and join it with and the negation of P. So I got to add a few more columns. I'm going to make a P implies Q column and get those answers here, a negation of P column here, and then I'm going to join these two results with and to get my final. So P implies Q. So true implies true, true. True implies false. There's the one that's false. False implies true, false implies false is true. Negation of P. So go to your P statement. True is now false, true is false, false is true, false is true. All right, now join this result of these two columns with and. Okay, so and is both have to be true. So true, false, 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 false is false. True, 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 true is true. Okay, but you had to create new columns so that you can see all this. All right. All right. One last thing, kind of a analyzing a truth table. and actually seeing why we make the whole table and then go back and look at specific parts of it. All right, so Lisa bought a new car and her uncle made this statement. If Lisa doesn't pay her registration, then Lisa will get a ticket for not having a valid license. Okay. Statements P and Q are defined as follows. P, Lisa pays her car registration. Q, Lisa gets a ticket for not having a valid license tags. Okay. Write Lisa's uncle's statement in symbolic form using P and Q. All right, let's go back to his statement. He said if Lisa doesn't pay her car registration. So P is she does pay her car registration. So he's talking about the negation of P. And it's if then, so it means conditional. So it implies Lisa will get a ticket for not having a valid license tag. Lisa gets a ticket for not. So what we got is negation of P implies Q. Based on this statement and these two, statements, or this conditional statement by her uncle and these two statements, that's how we'd write it. Okay. Now let's suppose the following situation occurs. Lisa pays her car registration and Lisa got a ticket for not having a valid license tags. Okay. We want to complete this truth table and see if the uncle's original statement makes sense. Okay, so let's take a look. Complete the truth table. So I got my P statements. There's all the possible combinations. So this would mean, P is Lisa pays her car registration. So in the first two cases, she does. In the second two, she doesn't. Q is she gets a ticket for not having a tag. Okay, so she got a ticket. She didn't get a ticket. She got a ticket. She didn't get a ticket. That's how it kind of works. All right, let's go ahead and calculate this. Negation of P. So I'm taking the P values and I'm interchanging them. So true is false, true is false, false is true, false is true. Okay. Now, negation of P implies Q. So false implies true is true. False implies false is true. True implies true is true. True implies false is false. Okay. So there's completing the table. Now, which one of these represents the scenario that happened here? She paid her car registration, so P is true, and she got a ticket for not having her license tag. That means Q is true, right? So that's the one our uncle's talking about. His statement is negation of P implies Q. So his overall truth value is, yeah, his uncle's statement makes sense. His uncle's or her uncle's logic is true because in the end, negation of P implies Q is true. And that's the scenario that we're talking about in the statement above. Okay. All right. So there's the information on truth tables. They're kind of, straightforward if you take a good approach here and just go right through your truth tables, identify whether it's conditional or, whether it's, excuse me, conditional, disjunctional, conjunctional. Make sure you know what the truth values are that go with those. All right. Well, I'll let you get at your homework.